So what is important in this? All the numbers. So 3 minutes for the comedy acts. 5 minutes for the singing acts. I heard the variables. Anything else? Ladies, please stop talking.
12 acts and 15 minutes.
12 acts and 50 minutes. Okay? And then it asks us to write a system. To write a system and model the situation. So that's what we're looking for. That was supposed to be skinnier. That's okay. Anyone want to take a guess as to what the two equations were? I heard 5s. I'm going to change these colors so they look different. It is. Plus 3c equals 50. What was the other equation?
S plus C equals 12.
S plus C equals 12. Right? Because we need to solve both. Because we need to solve both, it doesn't matter which one we start with. What do we want to start with? S or C? S. Okay. So if we're solving for S, how would we get S by itself? Subtract C. But if you did it the other way, that's fine too. So S equals 12 minus C. And what do we do with that? We plug it into the other S in the other equation. So this becomes 5 times 12 minus C plus 3C equals 50. Now what? Distribute. 5 times 12 is what? 60. There you go. That was the other one. That's okay. The other one. That's okay. It's okay.
I'm a good one. That was a good one.
Alright, and then what? What? Combine like terms. When we combine our like terms, what would that equal? -2.
I would have like 36 on it.
Okay. And now we need to solve for C. So subtract 60. 50 minus 60 is -10. What does C equal? 5. So that means there was 5 comedy acts. If there were 5 comedy acts, how many singing acts were there? 7. Right? We're going to go over the homework, but I realized when I went over this fifth period that the way I did the homework is one of the methods we haven't talked about yet. It's okay. Don't worry about the method we didn't talk about yet because that's elimination. That's why it looks different than what we've been doing. I will say the answer for these two, and then we'll talk about 3 and 4. So the answer, if you did this, the answers you should have got were the van had 18 students, the bus had 23. for number 1. For number 2, the adult tickets were $8 and the student tickets were $13. For 3 and 4, I did not expect you to solve these like we would solve the other ones because these were multiple choice. So because these are multiple choice, once you have your 2 equations, you can put the numbers in and see if they work. But remember, they have to work for both. So I started off with A. I put this into Abby's equation, but it didn't equal her total of $29.90, so that didn't work. The next one, I did this out of order. C didn't work. B didn't work, but D did. When I put it into Abby's equation, I got $29.90. And then when I put it in Josh's equation, I got $28.80. So both have to work in order for it to be an answer. For number 4, same thing, except I didn't have to do this 3 times because A ended up working. When you put those numbers into both equations, they work for both. Do we have any questions on this or on the warm-up? Yes. 5 and 7. C, I don't remember which was which. C was 5. Chicago, you had a question.
So for 3 and 4, like whenever it's like the answers are given for you, you said that we plug that into the equation.
Put them into the equation.
So we can find like that actual
number at the end, yeah? Alright, so today we are going to solve systems by graphing. Yay.
That's fun.
So, huh? Keep it. I would keep it. So I'm going to pass out your notes, but you can go get your phones. A couple of these together, this is going to help us start to understand how the system of graphing, solving systems by graphing works. So with these, we are given a solution. Our goal is to determine, are these an actual solution or are they not? So we're not going to solve them, but we are going to put this in. So because I have some x and some y, I'm going to put this 3 in for both of these x's, this 2 in for both y's, and see does it work. So let's do that. For the first one, that would be 2 equals negative 1/3 times 3 plus 3. What's negative 1/3 times 3? Negative 1. Does negative 1 plus 3 equal 2? Yes, it does. So I can say it's a solution for that first equation.
Yes.
But it has to work for both equations where it's not a solution to this system. So let's try the other one. Do the same thing. Put 3 in for x, put 2 in for y. Two times 3 minus 4. Will that give us 2? Yes. 6 minus 4 is 2. Now, because both work, we can say yes. This solution is a solution for this system. If one of them worked and one of them did not, it would not work for the system. Let's do another one. We're going to do 3. So we're going to do the same thing. Put 4 in for x, put negative 2 in for y. We don't need to rearrange this. We can do it just as is. Is this a true statement? 4 minus 4 times negative 2 equals 12. What does this equal? Negative 4 times negative 2?
8.
Positive 8. So then we're adding, which does equal 12. We still need to check the other one though. So put 4 in for this x and negative 2 in for this y. We know 3 times 4 is 12. Negative 2 times negative 2. Positive 4. Does this equal negative 4? No, it does not. So I can say that this is not a solution because it doesn't work for both. It has to work for both in order to be a solution. I want you to take like 5 minutes and do 2 and 4.
The rumors you
You get out the shower and then like this, like I don't know. Something else. It's like all kinds of
I know. Didn't you tell me to put me on my I spot big difference. What? There's a big difference in both of those pictures. No. You're embarrassing.
Mr. Ice. I know. You're sitting in the hot tub.
Huh?
The second one.
The one below it.
3x plus 2.
That time, you read a story. It's like, He's so fun.
Alright, eyes and ears up here. Looking at number 2.
Wake up. You gotta say that.
I don't care.
And my chair was comfortable, so was the floor.
Okay, eyes and ears up here. For number 2, do we agree or disagree with this answer?
Agree.
Agree. So this was not a solution because one of them worked and one of them did not work. The bottom one did not work, correct. For number 4, do we agree or disagree?
Agree.
Agree. This one was a solution. It worked for both. Now we're given 2 equations. We have to state the system. So we have to write what is one equation, what is the other, and find the solution. The solution is wherever they intersect. So right now we're just writing down the 2 equations and the point where it intersects. Yes. So I'm going to color these so you can see them so that I can refer back to them. That was terrible.
Oh,
The highlight makes it straight. Alright, for number 5, we need to write the equation of the green line. What would that equation be? Y equals
3 over 2x minus 4.
Let's see. I see this point right here, so if you go down 3 and right 2 is negative 3.
3 over 2. 3 over 2x minus 4.
X minus 4. So that's one of them. We need to find the equation of the red line now. Negative 3 over 2x minus 4. What is the red
2
line?
over 4x minus 2.
1 over half.
2 over 4 is the same thing as 1 over 2 x minus 2. Okay. Now, where do these 2 lines intersect?
Negative 2.
Negative 2, negative 1. That means that would work for both equations. It has to be a solution.
Oh, yeah.
So wherever they intersect, that is your solution point. It would work for both equations.
Oh, yeah.
Yes.
Where did you get the negative 1 from?
This one.
That's crazy.
You're going down negative 2, no, down to negative 1.
You don't get it.
Never mind. Do we have to solve for that, or is it just always
That's it. That's it. For this,
It should always.
for this, it only says to state the solution and state the system. That's all we're doing right now. Okay? So let's do one more. Alright, for number 6, we need to find the equation of the red and the pink or purple, whatever color you see here. So what would the equation of this pink or purple line be? Yeah, I got what?
-4.
4/1. I think that is right. 4/1 or just 4x plus 3, yes. And then your equation for your red line. Three over one, -3/1, or just -3x minus 4. -1 is our intersection point. Alright, go ahead and do 7 and 8, and then we'll come back and we'll talk about those two. We have them.
There's something wrong there. Apples taste like apples.
It's done. So that is $5.
I like apples. But the skin always stuck around.
And then you got the skin like. I've been dealing with that ever since I was so little. And then that's just where they meet, right?
I remember when I was this small, I so like I ate it out of
I'd eat like. Let's go, Emma. Twice the maybe even 4 times.
What?
I know.
you know well.
I knew what she meant.
Oh, that's what I did at the movie.
You're right.
But they just get one.
Whatever one you
I'll tell you about it later.
I know that they forgot to open that.
Wait.
Watch the portal, open, watch the portal. That's where I got that from.
Hi.
It's not good. I'm not.
I am trying.
Emma, so you just want me to help him out? So it's like annoying, like loud.
No.
She's just using your
Call it loud?
Yeah.
You got eyes on it? Emma, you already, your scene is doing them halfway. Your person is struggling. You guys are in legit. Your parents are like.
You would like.
No, I can be like
It's still.
See how it's going. Oh, good.
I can be like, who am I? Yeah.
Ours is easy. We just sit down with them.
Oh my God.
Because you can't walk around with
That's not right.
Allow your water.
You need to go first tomorrow.
Okay.
She was like, you were like, yeah. I was like, wow.
It was like
Yeah. I don't know why you don't know.
Alright, for number 7.
Where's that in?
Eyes and ears back up here. Or doesn't like me right now. Do we agree or disagree with number 7? Aiden, did you have a question?
Disagree.
I
Agree.
Yes, and we'll talk about that here in a second.
Oh, what?
I heard a disagree.
Oh, I should do that.
What do you disagree with? Me? Did you not disagree with that out here?
I said agree.
Does anyone disagree with 7 for anything?
No.
Okay. What about 8?
I agree.
Okay. So far, we have been given solutions. We had to determine were they solutions or not. We have been given graphs that intersect, and we had to state the equations and their solutions. Now, we're going to actually get into the solving piece. So make sure you're paying attention. So that means I shouldn't hear side conversations. Okay? You need to know 3 things when you are solving by graphing. If they intersect, they have one solution. So this is intersecting lines has one solution. Exactly one. Do these intersect? No. So what type of solution do you think these will have? No solution. It says these are created by parallel lines. What do we know about parallel lines? They have the same slope. So if you have 2 equations with the same slope, You don't even have to really graph it or solve it because it should be no solution because they won't ever intersect. If this is an identical line, so pretend that this is one line and there's another line drawn over top of it. This would be infinitely many solutions. What would have to happen with the slope and the y-intercept for this one? They'd have to be identical. They both have to be the same. Same slope and the same y-intercept. Okay, so for graphing, just like with algebraically, you can have 3 solutions, but it looks a little different when you graph versus when you solve. Not like me. Alright, so we are going to do one of these by hand, and then we're going to do, there's 4. I think we did 2 by hand. We'll do 1 by hand, and then we're going to do the calculator, and then we're going to use Desmos. So you will have the option, if you're solving by graphing, to use Desmos. I really need this to stop. Alright, for number 1, let's graph this by hand. How would we graph this first one, this first equation? Start at the y-intercept of 4. And then our slope is 1/2. So what directions are we going to go to get 1/2? Down. We can go down and left. So I could go down 1 and left 2 as many times as possible. Or we can go up 1 and right 2 as many times as possible. Yes.
But what if your line goes on the right side? Would it be wrong? Like graph it.
Like if you drew it this way?
Yeah.
Yes, because that would have a negative slope. Right? For this next equation, how would we start this off? Y-intercept of -3. And then our slope is negative. So what directions could we go to get there? Down and right. Can I go down 3 and right 1? No. So I can go, up 3 and left 1. Close that. Until I can't anymore. They do intersect. Wow, that was terrible. My line is my finger.
Intersect on the dot to count?
No. So that's a good question. They could intersect somewhere on the lines and it would still be considered a point, a solution. But for the most part, you should be able to see your solution point. So we've graphed them, but that didn't answer our question. What is our solution? -2, +3. So when you get these types of questions on the test, and it asks you to solve the equations, remember you'll have a choice of whatever you want. If you choose to solve it by graphing, I will need to see your graph and then put the solution. If you do not have your calculator, you need it. Yes, Aiden?
Can we be given a graph to do the second one?
Yes. Reset your calculators before we do anything else. 2nd plus 712.
I don't associate.
And then you're going to go to y equals, and you're going to put your two equations in. So we're doing number 2 right now. Does not matter which one you put first. 1/3 x minus 2 and alpha y equals. Are you sure? Yes. Right there. I don't have a for you. Katie just took it. I can sit in the hallway. Okay. So you're one of those numbers that I'll get in 1 second. Okay. After you have these two, press graph. Now, the disadvantage you have on your calculator is that yours isn't colored. You can't see it clearly. Mine is colored. So I could look and I could count, but just in case you miscount, there's a way to make certain that you get the answer right. Go into second trace. What do you think we're going to look for? Intersect. So choose number 5.
Wait, what do you press after you put in what you did?
We went to graph, and then we went to second trace. So it's going to ask you for the first curve. That's just asking, is this one of the lines? Hit enter. It's going to go to the other one. Hit enter again. Then it wants to guess. You don't want to guess. You want the calculator to do the work. Hit enter again. And it should tell you your answer. Yes. So graph it. Go to your intersection by going to calculate and hit enter 3 times. Alright, so for this one, I'm not going to graph this, but I am going to write down the solution we found. I don't remember what it was. -3, -3. Alright, we're going to do one more in your calculator, and then we're going to switch to Desmos. So let's do number 3. Now, Can we just put that into our calculator? No, we have to solve it first. Correct. It's just an option. Alright, so for this first equation, how would we solve that for y? Subtract x, so negative 4y equals negative x minus 4. And then what? Divide each thing by negative 4, so y equals, this becomes 1/4 x plus 1. So for the other one, we have to do the same thing, subtract our 3x. So negative 2y equals negative 3x plus 8. Divide each piece by negative 2. Y equals 3/2x minus 4. So now we can put this equation and this equation into our y equals. Sorry, not that one. This one. X plus 1, 3 halves x minus 1.
Yeah,
Make sure you have those in your y equals. And then go back to your graph. Now if you can count and you can see those numbers clearly, that's fine. Go into y equals. I do. Graph it. And then after this, go into second trace. Second trace, go into intersect. Hit enter 3 times. And it should give you 4, 2. You just need to show me the. So just in case you did not hear Emma's question, if you solve it on the calculator, you still need to show me your graph. Because you still solve this by graphing. Now, I'm not going to do that right now for lack of time. Alright, make sure you're looking at the board for this next one. We don't need to solve this with Desmos. We can put it in as is. So we're going to type in number 4's equations, put them in separate lines. X plus 3y equals 6.
Oh, we put it in like that?
Yes. And then x minus y equals 2.
Oh, wow.
So what's nice about Desmos is that it does this part for you. It graphs it for you, yes. But it also solves it. It like puts it in slope-intercept form without actually doing that. So that you could graph it. And then you can either count where your solution is, or you can tap it. I can't. It's not working for me.
Are you able to change the color?
Yes, but don't focus on that.
You like Desmos better?
Stop. No.
Now
Wait, how do you change the
Okay, Emma.
I still want to do the best, but for this is
Emma's being honest.
Hey, so to recap John's question, and this kind of goes back to Emma's question, if you use Desmos, that means you are solving by graphing. Yes, you still need to graph them. Okay? Let's do one more together. Look at number 5. It's asking you specifically just to find the x-coordinate, not the entire solution. So put those two equations in. 9x plus 2y equals 18. And x plus y equals negative 5. You may need to move your graph a little bit to see the solution. What is our answer to this? Wrong. It's just asking us to find the x-coordinate. So just 4. So pay attention to what it's asking for. Right? For 10 minutes, I want you to go through and see how many of these you can do using whichever method you want.